Welcome to all of you. Today we will discuss about one of the famous unsupervised machine learning algo, that is a k-means algorithm.
Now let us discuss about k-means algorithm. So k-means algorithm is an example of unsupervised machine learning modeling. So if you recall this supervised machine learning model, so that used to take the data with column names and the target values to be predicted, right? Whereas if you talk about this unsupervised machine learning model, it do not have a data with labels and target column. So basically it try to understand the given data by extracting the features and pattern on their own. They will not do any kind of predictions as we have seen in supervised machine learning modeling. So basically this unsupervised machine, this k-means basically it groups the element into various number of clusters. So to make data uniform, we use this mean max scalar concept. Basically this scale the data in between 0 to 1, so that we will see how this mean max scalar works. So let us discuss about this image. So let us see how this k-means clustering algorithm works. So here we are given the data set as like this. So here this data set contains the group of data points that might belongs to various cluster, or you may say the classes. Now we have to examine the data point and then classify them into groups depending on their nature, right? So here the number of clusters are represented by capital K. So then K means this capital K basically indicate the number of clusters, right? Since we have to divide this given data set into, let's say, the 3 clusters, so this K value for this data set would be 3, right? Now let us understand actually how this k-means algorithm, works. So for that regard, let me show you this algorithm first. So this is how our k-means algorithm will works, right? So it basically have a number of iteration. Actually this algorithm moves, and it start with some random point. It can be random, right? It can be any given point, or from any random point this algorithm will begin. And then we try to calculate the equilibrium distance from this random point from all the given points, right? And then again after the one iteration, we again find out the new centroid, and this process of calculating the distance from the new centroid will keep repeating over the number of iteration until this updation of centroid will not be stabilized, right? Till then this algorithm will move on. So let me show you how this algorithm will works with the help of examples. You see here what I told you, same thing I am representing by this example. Let's say I am having a number of A15. Total 15 points are given to us, and these are the coordinate of those points, right? So how this k-means will start? So as I told you, randomly choose the 3 centroid, because let's say k value is equal to 3. So it will become, this algorithm will start with this randomly selection of the 3 centroid. Let's say A2, A7 and A15 we have selected as a random centroid, right? So now what we have to do, see, we have to again now calculate the Euclidean distance from all this 15 point from the each centroid, where the centroid 1 is representing is associated with the cluster 1, centroid 2 which we have selected as a randomly is associated with the cluster number 2, and centroid 3 is associated with the cluster number 3. Okay, so with this understanding, now let us calculate the Euclidean distance of all the points from this centroid. So to represent the distance, I have created this table. This table has been given to us. So here you may see the A1 is 4 point away from this point 26, whereas this A1 is having a distance from this centroid is 3. A1 distance from this centroid is this much. Now based on this distance, you may understand that A1 is actually falling down in cluster number 2 since this distance is minimum, right? Similarly, if you see this A2, again out of this 3, you may see this A2 is this number is minimum. It means this A2 will fall down, or it will be in vicinity of cluster number 1. Similarly, we will categorize all this 15 point and we will check out in which centroid, which cluster, the point is nearer to which cluster number, and accordingly we will label that. Okay, So after the first iteration, you may understand that in cluster number 1 we are getting this many points. Let's say you may see over here in cluster number 1 we are having a point number A2. In cluster number 1 you may see point A5 is also falling down. In cluster number 1 A6 is also falling down. Cluster number 10 also is nearer to cluster number 1. Similarly, A12 is also close to cluster number 1. Similarly, the A14. So, in cluster number 1, you may see there are total 6 points, right? So, based on this 6 point, again we have to calculate the new centroid by finding out the mean of x and y, right? So, this would be the new updated mean. Similarly, in cluster 2, we are having a 5 points. So we have again, based on this, we have to again calculate the new centroid point. Let's say it is a 4,9.6. Similarly, with respect to cluster number 3, you will get the updated new centroid. Now again, we have to calculate the Euclidean distance from the new updated centroid. So this is my new updated centroid. This is centroid number 1. This is centroid number 2 coordinate. This is centroid number 3 coordinate, right? Again, we have to find out the distance, Euclidean distance of all the points with respect to these 3 updated centroid. Again, you will see we have calculated the Euclidean distance between point 210 from this point 3.833 and 5.167. Again, if you find out the Euclidean distance, this would be the value of that. Now, similarly, we have calculated all this value. So, you may see here, again, this A1 point is falling down again in cluster number 2, right? Because out of this 3 value, this value is minimum. It simply means this A1 is in vicinity of cluster number 2. So, this cluster number 2, you may see over here. So, this A1 point is going to be assigned to the cluster number 2. Similarly, if you find out the distance from A2 with respect to all the centroid, you may understand that this A2 is going to be assigned to cluster number 1. Similarly, A3 point is going to be assigned in cluster number 3, and so on. Based on the Euclidean distance, we will figure out this part. Again, we will keep repeating this process, right? Again, let's say we will calculate the new updated mean based on how many points are there in cluster 1, how many points are falling down in cluster number 2, how many points are falling down cluster number 3. Based on that information, let's say in cluster number 1, now in updated way, in the second iteration, we are getting 5 points are falling down. In cluster number 2, we are having a 7 points. In cluster number 3, we are getting 3 points. Again, based on this value, new updated points, again we will calculate the new centroid, right? So again, this iteratively we have to perform these steps, and again we have to find out the new Euclidean distance of all the points with respect to this updated centroid point. Again, you must see this A1 is falling down cluster number 2, A2 is falling down cluster number 1. See, this process will keep repeating until this new updation of the cluster is not stabilized. So you may see here, at this point, in this our case, at this point in cluster number 1, again we are getting a 5 points. In cluster number 2, we are getting 7 points as we were obtaining in the previous iteration, right? So we are not changing the centroid. When this updation is getting, is not getting updated, at that point this algorithm will stop. So that is the basic idea how this k-means clustering works. So I have discussed about the algorithm. Let me show you how actually this works. So basically that is the idea. This algorithm will start randomly, and iteratively this algorithm will move and keep updating the centroid. So this process will keep repeating until the change of centroid will not be stabilized. So that is the basic idea how this k-means clustering works. Now let us come back and let us see how to implement this k-means clustering over some given data. So for that regard, what I did, these are the basic libraries which we have imported. So I am having this data called this income.csv. So basically this data set contain data about the employee name, age and income. So basically it has a 3 column and it has a 22 rows of the various employees, right, who has an income at various level. Now we have to classify the employees into the cluster or group depending on their income. That is something which we need to perform. The question here is how many level of incomes are there? right? So that is something which we have to understand. So in this data set, this if you see, these names are not important, right? Because they cannot indicate any group, but age and incomes are having a some sort of relationship. Hence, let us first show their relationship. Let us understand, let us figure out the relationship between age versus income. And we know that for establishing a relation, we used to use this scatter plot. So to show the relationship between age and income, I am using this scatter plot. So I have given the value. So if you see this scatter plot, if you visualize this graph, then you may see there are three groups of the data point. That means there may be three group of income. It is possible that we instruct the k-means clustering model to divide the data into three groups. So for this purpose, firstly we should let's say create an object of k-means class taking the parameter n cluster is equal to 3, right? So based on this visual information, I am passing this value k is equal to 3, right? Now so this method, I mean this class is already available in sklearn. So we are passing this value as a parameter into this k-means. So this is the object of that k-means class. Now to train the model, we should use this fit predict method, right? So once we execute this one, now my model has trained, right? So if you observe this y predicted, they may represent three labels like a 0, 1 and 2, into which all the rows are classified. We can understand that first two records are kept in cluster number 2, and the next two records are in cluster number 0. I mean that is a cluster number 1, you may say, and then other R's are falling down in another cluster, right? So that is the idea. I mean that is the observation which we can figure out after by seeing this y predicted, right? So now we should verify that how for this type of grouping or classification is correct, right? So what we are going to do this, we will add this cluster number as a new column by the name cluster. So for that regard, what I am doing is this output, I am creating a new column, name of that is cluster, that we have appended in our existing data frame. So if you add it, so you must see this first 5 rows of the resultant data frame are is shown over here in that is a preceding output. Let us find out the coordinate of each cluster center, right? So this can be obtained from the property of this cluster center, right? So with the help of this cluster center, we can obtain that center, right? I mean, we can find out the coordinate of each cluster center. So if you execute this one, so you must see this, these are the center of that. Now, since we have figured out that there are 3 clusters, so we have a 3 pair of coordinates, right? 3 pair of coordinate we are having. So the 0th column represent the x coordinate, right? And the first column represent the y coordinate of the 3 centers. So we can also represent this point like this, right? We can represent them like this. Okay, so now after this what we have done, so let us separate this 3 cluster into 3 data frame depending on the cluster column, cluster column value. So that means the cluster number 0 represent the data frame 1, cluster number 1 represent the data frame number 2, cluster number 2 is representing the data frame number 3, right? So that we have done over here. So now let us draw the scatter plot representing 3 clusters along with their center. Here the data points of the first cluster are shown as green, and the second clusters are shown as red, and the third cluster is shown as black, right? So various markers are used to present this data point. So here we have used O, here we are using a diamond, here we are using the S, right? So various marker we can use for that regard, for representing it. The first cluster point are shown in form of this O is nothing but the circle. The second cluster point are shown in form of diamond, and the third cluster point are shown as square. So this is the outcome of that. But if you see this, the outcome of this k-means, if you see thoroughly, if you observe this three center point, which are in color as a purple star, right? Purple star, right? These are the center, right? So you may see this. These data points are not classified properly, right? The points are not close enough, right? So if you see this cluster, this data point are not very close enough to this centroid. Same thing is true with this last clustered, right? It means something abnormal has happened, right? So what is the reason behind it? Why data points are not classified properly? So that is the main question, because we have followed everything whatever has been we have learned, right? So the reason is that the data contain non-uniform values. That is the main important part, right? For example, if you see this age and income column may contain too big and too small value that cannot be fit properly by k-means clustering model. Now the solution of this problem is we have to make the data fit into the proper scale. So for that regard, actually we use this mean max scalar, right? So this mean max scalar is a class that is present in this sklearn pre-processing module that fit the data in between a minimum and say maximum values. Generally, if you see this, this mean max scalar generally fit the data in between 0 and 1, right? So let us understand actually how this mean max scalar works. So for that regard, one example I have taken over here. So it firstly takes the actually original minimum and original maximum value in a column of data, right? So in each column, let's say the minimum value is 26, let's say 43 is the maximum value. So after finding out the mean and max of any column, it basically find out the difference. So basically difference between this mean and max is 17. This is nothing, it is called as a range, right? Now after calculating this range, the next step is for each value in a column, mean max scalar subtract the minimum value in the column and then divide it by the range, right? So this is how actually it operates. So after performing this operation, the original value 27, 29, 29, which was present in each column, actually that is converted into 0.05882, 0.17647, 0.17647, like that way. So you may see the range basically, these values are in range between 0 and 1 and represented a uniform way, right? So that is the important part. Now after this conversion, this value will become suitable to be used for k-means clustering model. Now let us now convert the data frame into the uniform data using this mean max scalar practically, right? So what to do here? After doing this transformation, so we have transformed this age and income column. After this transformation, now my data is ready. Now we can apply k-means clustering model on this data to do classification, right? So this is my data. Now this is a scalar value. Now my data is ready for doing this k-means classification. So what we are doing is we are going to be apply. So firstly we will create the object of k-means class with the k value is equal to 3, and then we will train it by using this fit predict method, right? So once we done it, now this is the outcome of that. So this above outcome, represent that k-means model has divided the income into three categories, 0, 1 and 2, right? Three groups you may say. And now what we have to do, as we have done earlier, we have to add this group number to the data frame as a new column by the name, let's say the cluster, right? So that we are creating a new column, right? The name of that is a cluster that we have appended into the existing data frame. Now after doing it, the next step is we have to find out x and y coordinates of the cluster center for the three clusters, right? So that we have done by executing this command. So after that, the next step is we have to separate the data frame into df1, df2, df3 based on the cluster number, and that we have done after executing this statement. Finally, after doing this this step, Finally, we are drawing the scatter plot for the 3 data frames along with the cluster center as we already did previously, right? The same like that we are doing over here. So if you see this outcome, we can understand that data points are properly grouped by the k-means clustering model. Now this figure shows that 3 groups are aligned with their data points for better understanding, right? Now the you may say how to know about the k value, right? Because by the visual inspection of our original data, we said that there is a more likely 3 clusters are there. But how algorithm will understand that in the data set how many clusters should be there, right? So for that regard, we are having a one method called algo method. So I mean, in our case, by seeing this visual inspection, we have decided that 3 clusters should be there, right? So that's why in k-means n cluster value we have kept as a 3. Now, but that is not the correct way to decide the optimum number of clusters. This visual inspection in 2D maybe we can do, but if the dimensions are more, then it is very hard to understand about it, right? So that is not the best way, best approach that by seeing data, by doing a visual inspection, we will decide the value of k. So for for knowing the k value, we are having a method called algo technique. So basically, in this technique, we have to draw a plot between the values of k and sum of square error, right? And we have to see where the algo point occurs. So this will give us the correct number of cluster into which the data should be grouped. Now, so to begin with, what we done over here, let us take the k value range from 1 to 10. Also, let us take the empty list, right? This SSC, where it is going to be stored the SSC value. We will then train the k-means model for each value of k and obtain this SSE value. To train the model, we have to use this this fit method, right? This km.fit method for training purpose. So to get the sum of square value, we have to use this km.inertia property of the model, right? So after this, we can append this SSC value in each turn to the list called this SSC, right? After each iteration, we will get the updated value of SSC that we are appending into this list. Now that we got the k values in k range, k underscore RNG, and the SSC values in the list of SSC, now we can draw a plot between k underscore RNG and SSC, right? So if you plot it, so it clearly shows that algo point is at 3, and hence the optimum value of k should be 3. That means given data point can be classified into 3 groups in the best possible manner. This is what we have got from the k-means model, right? Now, after doing this much, as we are doing in a supervised learning model, we used to check the accuracy of the model. Now, concern comes how to check the accuracy of k-means modeling. So we should not measure the accuracy of k-means clustering model as we do not train the model with the label data. So that is something which we have to understand. Now to know how it is performing, we may compare the scatter plot of the original data set and the scatter plot of this k-means data set, k-means clustering. So this scatter plot tells us if the classification is reasonable or not, right? So that thing we have to understand. Now another important thing is k-means demerit. So let me show you that one. See, in number of cases this k-means actually fails, right? So maybe if you are having a banana shape of data, so this k-means is not going to perform over there. If you are having a concentric spheres data, right? In that case also this k-means clustering fails. So there are certain demerits are associated with the k-means algorithm. So that we have to understand. Now, now to expand it further, what I did, we are going to be load another data set that is present into the scikit-learn.org, and that data set is nothing but the iris data set, right? So that we are loading that is available in sklearn.dataset, so that we are importing. Now this dataset contains total 150 rows, that is related with the 3 flowers. Already we are using this data from very long. So basically it is a bunch object. We can see the column names by referring to iris.features underscore names. So these are the column names, right? So there are basically these 4 columns, and we will be considering only 2 features. Let's say petal length and petal width, right? Petal length and petal width we are going to be considered. So as we have done earlier, we have to first of all scale the petal length and petal width data using mean max scalar, right? And then we have to draw the elbow plot for a range of k value, right? And after finding the optimum value of k from the elbow plot, we can use it in k-means model to divide the flowers into group of cluster, right? As we have done earlier, the same procedure we are following here. So here the number of cluster, we will check it out based on the k value. So k value is here clearly is coming as a 3. So this k value will pass as a parameter to k-means, and we will follow the same step as we did earlier, right? So if you follow those things, you may see this is the resultant of that, right? So there are 3 different cluster you will obtain if you will perform k-means over the iris dataset by selecting only 2 features, petal length and petal width. So that is the outcome of that. Now the most important part, what is the takeaway point from this k-means clustering? So this k-means clustering is a popular unsupervised machine learning algorithm that is used to group similar data point into cluster, right? That is the first takeaway point. Second is the pros of k-means clustering include its ease of interpretation, scalability, and ability to guaranteed convergence. What is the cons of k-means? The cons of k-means clustering include the need of predetermined number of clusters. So that is the main drawback, right? You must know k value in advance, then only we can apply this k-means, right? And this is sensitive to the outlier and risk of getting stuck in the local minima. That is the cons associated with the k-means clustering.
Now let us summarize what so far we have learned in this k-means. So supervised machine learning models take data with column name, that is called as labels, and target value to predict the outcome. Whereas in unsupervised machine learning, model do not have a data with labels and target value to be predicted. Now here they try to understand the given data by extracting the important trends or patterns on their own. So this k-means clustering is it is a unsupervised machine learning model that group the element into various cluster. Now here concern is how to find out the k value. So for that regard we use this famous elbow method. So this elbow plot that represent the relation between k values and sum of square error, that is known as SSE. Now in this plot the elbow point should shows a dip. That point among the k value represent the optimum the k values. Now to make the data uniform, we use mean max scalar that scales the data between 0 and 1. Thank you.